Hi everyone, my name is Catherine. So I'll be talking about best practices for multilingual LLM evaluation. So the kind of like scenario I'm envisioning is you're asking what's the best model for my target language, or you're trying to evaluate whether the method that you employed improved performance for your target language. And actually the best practices I'm going to be talking about are the same for all languages, high, low resource, everything. It's just that in a low resource scenario or a multilingual scenario, it's even more important to adhere to these best practices because you're often operating with fewer benchmarks, and so each one of these benchmarks holds more weight in your answering these questions. So first I'm going to talk about some best practices for selecting benchmarks. Then I'm going to talk about how to actually run them to evaluate multilingual models fairly. And then I'm going to just have some brief thoughts about creating some new multilingual benchmarks. So just before I go into the best practices, a note about benchmark availability, which is the problem that I run into the most actually. So for English and Chinese, other pretty high resource languages, you generally have benchmarks that exist for the task that you're interested in, but there's a pretty steep drop off in availability as you go into lower resource languages. So this is a nice figure from a recent paper that shows for English and Chinese, I mean there's even still a pretty sharp drop off from English to Chinese, and then once you go down, there's a very long tail of languages for which there exist very few benchmarks. And so just to note that depending on what language or languages you're working on, some of these best practices are actually very hard to adhere to because you just don't have a lot of options in terms of benchmark selection. So the first one is just choose tasks with appropriate difficulty level. As I said, this may seem trivial, but sometimes this is actually a very hard criteria to meet. So especially many benchmarks that exist that cover a lot of languages are too easy for our kind of like current models. So some examples are Civ 200, which is a topic classification task, covers 200 languages, but it's really not going to evaluate our sort of like more recent, like very large models. One that was released just last month is Multilingual, which evaluates sort of ability for models to generate grammatical text. It covers 100 languages. I'll talk a little bit about this one. And this is largely due to the temporal disconnect between when benchmarks are created and when they're actually used to evaluate models. So by the time a benchmark has come out, and maybe like a year later, our models have really moved on in terms of what they can do, but we're still using the same benchmarks, especially for languages other than English. And so as a result, these benchmarks can't really help us distinguish between two models or help us with model selection. Just to illustrate this with Multilingual, so this task basically evaluates whether a model assigns higher probability to a grammatically correct sentence than a grammatically incorrect sentence that's minimally different. And this is predictive of grammatical text generation, which is not a solved task for many languages. And so looking at the results, for English, we're pretty much at ceiling. All these LLM models are getting 99% basically. For the high resource languages, LLM models are getting 95, 96, 97%. So this was just released and already it's kind of saturated. For even like an 8B model, we can pretty much do this. So here's an example. So Multilingual kind of has good language coverage, but it doesn't meet this first criteria. The second sort of recommendation is to avoid machine-translated benchmarks, especially ones that haven't been verified by experts or native speakers of a language. Machine translation introduces noise into benchmarks, so basically getting in the way of our ultimate goal of estimating model quality using these benchmarks. And this is even worse for low resource languages. So to walk through an example, this is the EU 21 benchmark, which is covers 21 European languages. There are several tasks, MMLU and some other like quite widely used tasks. and they machine translated all of them from English into the various languages. And so you can see performance on the right of basically a descending order, just lower performance as you go down. And this is very tightly correlated with the amount of training data that we have for these languages, what proportion of Common Crawl these languages make up. And so we might attribute this particular model performance difference to training data, but it's confounded between also the resource level of the machine translation system that's being used. So are we seeing lower performance in Estonian because the model is worse in Estonian, or because the translation system is worse for Estonian? Probably both of them. But this is really a problem, especially when we're trying to compare performance between two languages within a single model. So the EU21 MMLU, the good thing is it covers several languages. It is challenging, but it does kind of not meet this machine translation recommendation. Next is avoiding automatic evaluations that don't correlate with human preferences. So thinking about tasks like summarization, which have open-ended generations, it's pretty common to use things like Rouge or Bleu score. Increasingly common to use LLM as judge to evaluate summaries. But these automatic metrics and LLM judges need to be extensively evaluated and aligned for each language. So it might be quite difficult to expand this to different languages, so people don't always do that. This study found that LLM judges were able to produce correct, fluent text in Korean, but we're not able to actually distinguish between cases of cultural misrepresentation, exactly kind of where you want these models to work. And this study, done in collaboration with some people at Eleuther, found that across 3 different languages, so English, Chinese, and Indonesian, across various features, Rouge, Bleu score, and GPT-4 as judge all showed pretty poor correlation between human preferences. So we're really not doing a good job at successfully evaluating open-ended tasks like summarization. And we're currently working on expanding this study to more languages to better understand how to successfully do this. So for example, an evaluation like XLSum, which uses Rouge as an evaluation, it covers 44 languages. It is challenging. It's not machine translated, but it uses these automated evaluations, which can be problematic. Fourth is benchmarks should be culturally appropriate and adapted to the target language. So localized benchmarks show higher correlation with human judgment, and this means they're not just translated, but they're culturally adapted to, say if it's a legal benchmark, then it's adapted to specific laws in that country, something like that. Some examples are CMMLU and KMMLU for Chinese and Korean, and recently Cohere released Global MMLU, which has 2 different sections, but one of them has a cultural specific subset. So all of these are good examples of how to successfully adapt MMLU to localize MMLU to other languages. So Global MMLU does a pretty good job on all these recommendations. And the last one in this section, use tasks and metrics that correlate with human judgments. So some tasks in general might better be predictive of sort of general chatbot arena kinds of scores. So they might be more useful to us. So this study found that multilingual grade school math benchmark more closely correlates with MMLU, more correlates with human judgments than MMLU. I think they also found in general that reasoning and math benchmarks were better predictive of human preferences. And in the absence of that data, which we don't have for many languages, it's good to just pick benchmarks that match whatever your desired use case is, especially, there are limited benchmarks available. So multilingual grade school math kind of meets all of these criteria, although it has the worst language coverage of all of them. So like we have this balancing act between like meeting sort of these best practices and then actually having good language coverage. So there aren't any perfect benchmarks. I haven't really ever seen one, and certainly not one that covers a very large number of languages. So yeah, depending on what language you're working with or languages you're working with, sort of what you're doing, all sorts of things, I think it's good to just keep these best practices in mind, try to adhere to all of them, but I often fail to meet many of these due to constraints. And yeah, they apply to all languages, including English, but as I said, they're more important the fewer benchmarks you have. So I'll just speak briefly about evaluating multilingual models fairly. So an important thing is to use either confidence intervals or standard error depending on your evaluation setup. So this is a result for a GPQA for a few models with just one run. And then this is the confidence interval setup for over 10 runs. And these leave you with very different impressions of which model you should use, I think. And so, this might lead you to choose GPT-4 Turbo, which is going to be cheaper for you. So that's this is really going to have big consequences for whatever your application is. So I think, yeah, confidence intervals and standard error help you make more informed decisions once you've chosen your benchmarks to use. Also, make sure to use a consistent and replicable implementation. We found that even just changing white spaces in the prompt can drastically change benchmark scores. So these small implementation details matter a lot. The good news is you can get both of these things and many other things from the LLM evaluation harness, which has been around for a little while and supports many benchmarks. So it automatically will compute standard error for all of your benchmarks. It uses a replicable evaluation strategy, and you just run a single line of code and it runs your evaluation for you. This is really life-changing if you haven't used it. If you want to learn more about sort of these implementation details, this is a paper. We're releasing an updated preprint pretty soon. Didn't quite get it ready in time, but this is a really great paper if you sort of want to learn more about these things. And then in terms of reporting benchmark scores in a multilingual setting, it's important to disaggregate your benchmark results across different languages, because aggregating them by just meeting the accuracy across all of your languages is really going to hide some important information about, especially where your model is not doing well, of which languages your model is not doing well on. So these are some multi-blend scores for two sets of models. So Llama 7db, these goldfish models. The mean accuracy is pretty similar, but if you look at the distribution of scores across the different languages, the goldfish models have sort of more consistent scores across languages, and Llama has more languages for which there are lower scores. So Llama has some languages it's not doing very well at, but you can't really see that just from the mean score. So it's important to look at these, understand the full distribution of the performance across all the languages, and report that as well. And so I'll just briefly speak about our ideas about creating new multilingual benchmarks. So of course we're going to keep all these best practices in mind that I've mentioned. So when we're considering which tasks are we going to sort of focus on, if we're going to do any translation, using expert translation, localizing if relevant. We're going to try to get validation from human preferences, that kind of thing. And the main goal is to improve language representation and sort of focus on this long tail and try to, have more benchmarks available for more languages, which I see as one of the critical problems. And we intend to do this through large international collaboration. I think Like we need experts from various different language communities. We also just want perspectives from people who have like many different use cases. And we're currently developing a multilingual, naturalistic, open-ended question answering benchmark in the Eleuther community. We are looking for collaborators and contributors, so if this is something that you're interested in, get in touch with me after, or I'll have a link at the end to join the Discord. Right, so just wrapping up, all the recommendations and best practices that I talked about are in this blog post that I just published. And here's the link to the Discord if you want to get involved or just keep up to date with what Eleuther is doing, either multilingual benchmarks or about other topics. So that's everything. Those are the same QR codes.